In Chapter 3, Section 2, we are graphing linear equations. Our objectives are to identify linear equations and graph a linear equation by finding and plotting ordered pair solutions. In the first set of examples, we want to determine whether each equation is a linear equation in two variables. What is a linear equation in two variables? A linear equation in two variables is an equation that can be written in the form of ax plus by equals c, where a, b, and c are real numbers and a and b are not both 0. This form is called standard form. The first equation we see, 5x equals 2 minus 0.6y, can be written in standard form. In fact, if we add 0.6y to both sides of this equation, the result is the equation 5x plus 0.6y is equal to 2. So we can see that it's in standard form, and a, b, and c are real numbers. So this is a linear equation in two variables. Now in terms of the part b here, we have y equals x squared minus 4. If we were to write both x and y terms on the left side of the equation, we can do that by subtracting x squared from both sides. But then our resulting equation ends up looking like a negative x squared plus y equals a negative 4. This is not a linear equation in two variables, because we have a squared term for the x. Instead of ax plus by equals c, where x and y are both powers of 1. Now let's look at example c, y equals negative 2/3 This is an equation that is a linear equation in two variables. You can write this in the standard form, if you can identify that 0 is the coefficient of x plus y equals negative 2.3. So this is a linear equation in two variables. In part D, we can rewrite this as well by subtracting x from both sides, and we end up with we can also subtract 47,026 from both sides of the equation. So that our resulting equation is negative x is equal to we can then write this equation in standard form as negative x plus a 0y equals negative 47,027. So we can say, yes, this is a linear equation in two variables. For each equation, find 3 ordered pair solutions by completing the table, then use the ordered pairs to graph the equation. These will both be linear equations, and the graphs will be straight lines. We're going to complete the table for the first equation, and we see that x is equal to 3. So we want to determine the value of y when x is equal to 3. If we let x equal 3 and plug that into the original equation, we end up with 3 minus y is equal to 2. By solving this equation for y, we will be subtracting 3 from both sides of the equation, and the resulting equation will be negative y is equal to negative 1, so that means y is equal to 1. We can fill in that part of the table when x is equal to 3, y is equal to 1. Now let's look at the second row of the table. We see y is equal to negative 2. So if we let y equal negative 2 and plug that into the original equation, we have x minus a negative 2 is equal to 2. X minus a negative 2 is the same thing as x plus 2 is equal to 2. And by subtracting 2 from both sides of this equation, we get x is equal to 0. So we can plug that into our table. And then finally, the x is equal to -1. We plug that into the original equation, and we get x, which is -1, minus y is equal to 2. And we solve this equation by adding 1 to both sides, and we end up with -y is equal to 3, and that means y is equal to -3. We can plug that into the chart. Now we're going to plot these 3 points on the graph paper. Now I start off with a blank graph paper. There's no scale on the x or y axis, so it's really important that we should label those. We have the x-axis and the y-axis. And now we can plot the first point at 3, 1, 1, 2, 3. You can mark in each direction. It's a good idea to do that so you know the scale going in all directions. So when x is equal to 3, y is equal to 1. It's our first point there. When x is equal to 0, y is equal to -2. And when x is equal to -1, y is equal to -3. Now we see 3 points that are on that line, and we can connect those. And graph the resulting linear equation. Let's continue with part B. In part B, we're going to complete the table first when x is equal to 6. We're going to rewrite the original equation replacing x with 6. So we simplify this. We get -1/3 times 6. We can multiply fractions. That's -6 divided by 3, which is -2 minus 2. So we get y is equal to -4. Now let's look at solving the equation when y is equal to -3. If y is equal to -3, the resulting original equation becomes -3 is equal to -1/3 x minus 2. We're going to solve this equation by adding 2 to both sides, and then our resulting equation would be -1 is equal to -1/3 x. To eliminate this coefficient in front of the x, we're going to multiply by the reciprocal. The reciprocal of -1/3 is -3/1. And we're going to multiply both sides of that equation by -3/1. And -3/1 times a -1 is a +3, so we get +3 is equal to x. And we can plug that value into the table. Now finally, the last point we're looking at is when y is equal to 0. So you're going to replace the y in the original equation with 0, and we get y 0 equals -1/3 x minus 2. We're going to add 2 to both sides, and then the resulting equation is 2 is equal to -1/3 of x. We're going to multiply both sides again by the reciprocal, -3/1. So -3/1 times 2 is -6. And -1/3 times -3/1, those will divide out to give you just 1x. So x is equal to -6. Now we're going to plot those points. Starting with when x is 6, we can, again, denote the scale. We don't have to mark every number, but it's a good idea to do at least one in each direction, so it's really obvious what the scale is. And we're going to plot the first point at 6, -4. The next point is at 3, -3, and then -6, 0. We're going to connect those points with a straight line. Let's graph y equals 2/3 x by completing the chart. We begin with x equals -6. We're going to replace x in the original equation with -6, and we're going to simplify the result. And when we multiply 2/3 times -6, we can multiply 6 times -2 to get -12/3. And -12/3 is -4. So we can plug that number into the chart. Now let's look when y is equal to 0. We're going to plug 0 in for y into the original equation. And when we solve that, we see that even if we multiply both sides by the reciprocal, 2/3, the reciprocal of 2/3, which is 3/2, 3/2 times 0 is 0, so we get x is equal to 0. So this line is going to go through the point 0, 0, which is the origin. And then finally, our last y value is 10/3, so we're going to plug in 10/3 into the original y part of the equation. 10/3 is equal to 2/3 x. Solve this by multiplying both sides by the reciprocal of 2/3, 3/2, and 3/2 times 10/3. You can simplify this. We know that the 3's will divide out, and the 2 goes into 10 5 times, and we find that x is equal to 5. You could also multiply 3 times 10 to get 30 over 2 times 3, 6. 30 divided by 6 will give you 5. Now we can plot these 3 points. Let's begin with labeling the x and y axis. We can label out to 6. In all directions. We can plot the points, -6 in the x direction, -4 in the y direction, 0, 0 is a point, and over 5 up 10/3. Now 10/3 is 1, 2, 3, and 1/3. Now we can graph a line that goes through those points. Now the lines do go on forever, so that's why we put arrows at the end. In part D, we have the equation y equals -3. This is a linear equation, but it's a special one because it only has a y value that x is missing. This is a special case, because no matter what the x value is, the y value is always going to be -3. So when you're completing the chart, when x is 2, y is -3. When x is -1, y is -3. When x is 0, y is -3. It doesn't matter what value of x, the y is always equal to -3. This equation is missing the x, so the x's can be anything, but the y in this case will always be -3. A way I remember these special cases is using this phrase, HOY and VUX. And this one falls into the HOY category because the H is going to stand for a horizontal line, and the O is actually a 0, which means that the slope of this line has a 0 slope, which we'll get into in a section coming up. And then the y means the equation only has a y, and the equation can be written as y equals a constant. When we plot these points, when x is 2, y is -3. When x is -1, y is -3. And when x is 0, y is -3. If we mark the scale here in the x and the y direction, and we can draw a line that goes through those 3 points. Now notice this is a horizontal line. The slope of this line is 0, and the equation is only in the form of y equals. Let's graph the following linear equations. We can do that by making our own chart. The first equation we see is x plus y equals 0. When I make a chart, I like to begin with a table using x and y, and then I usually like to choose some positive numbers, some negative numbers, and zeros. So I can begin with, say, a number like -1, 0, and +1 for x, and then I'm going to plug those in to find the y values. When I solve the first one, when x is equal to -1, I replace the original equation x with a -1, and I get -1 plus y equals 0. I can solve this equation by adding 1 to both sides, and I get y is equal to 1. Now let's do the second part of the equation, or second value in the table. We have x is equal to 0. So I'm going to replace the x in the original equation with 0. So I get 0 plus y equals 0. In other words, y is equal to 0. So I have my second point. Finally, let's replace the x with 1. So I get 1 plus y is equal to 0. And then I solve this by subtracting 1 from both sides, and I get y equals -1. Now I can plot these points, again labeling the scale in all the directions. And then I'm going to plot the 3 points at -1, 1, 0, 0, and 1, -1. Now you can plot even more points at that. You can choose other values. You want to get enough points so it's clear where the line should be drawn. Let's look at part F, y equals -2x minus 1. We are going to make a table of values, x's and y's. I'm going to choose some positive values, negative values, and 0. Again, you can choose any x values you want. Just may need to adjust the values that you choose so you get a complete graph. Let's replace the the x in the original equation with -1, -2 times x, -2 times -1 minus 1. By simplifying this, we get y is equal to -2 times -1 is +2 minus 1, or y is equal to 1. Now let's replace the original equation x with 0. Y equals -2 times 0 minus 1. And we solve that to get y is equal to -1. And for our last point, we are going to replace the x in the original equation with a +1. So we get y equals -2 times 1 minus 1. And when we simplify that, we get y equals -2 minus 1, or -3. Now we can plot those points, again denoting the scale. Plotting each point, -1, +1, 0, -1, and 1, -3. Draw the straight line that goes through those points. And you can see that we have a linear equation. Finally, we have the x minus 2 equals 0. Again, this is another one of those special equations because it only has an x, it doesn't have a y. Remember the phrase HOY and VUX. This was from our previous slide where horizontal lines have 0 slope and the equations only have a y. Now the VUX is the vertical lines have undefined slope and they only have an x in the equation. So again, V is going to stand for vertical line. U means undefined slope, which we'll get into later on in this course. X is equal to, that means the equation only has an x equal to some constant. We can make a table of values and plug in, we get x and y. And if we take our original equation and add 2 to both sides, we get our original equation can be written as x is equal to 2. So no matter what the y value is, the x is always going to be 2. So even when y is equal to, say, a -1, the x is going to equal 2. When y is equal to 0, the x is going to be 2. When y is equal to 1, the x is going to be 2. It doesn't matter what the y value is. There's no y in the equation, so it could be anything. But in this case, the x is always going to be 2. Let's sketch this linear equation. by plotting those points that we have in the table. When x is 2, y is -1, x is 2, y is 0, x is 2, y is 1. And we could see that this ends up being a vertical line. That's the VUX. V for vertical, U is for undefined slope, and the equation of the line is written in the form of x equals a constant. In this problem, we want to solve. The value of a house y increases in value x years after purchase by the formula y equals 7,500x plus 120,000. Let's graph the linear equation. We can do that by making a table of values. Let's choose a few x values that would make sense in this particular problem. X equals 0 would be the value x years after purchase. That would be the value of the home at the time of the purchase, so x equals 0. Negative values for x wouldn't make sense for this problem. We can look at values such as like x equals 5 and x equals 10. You can go on further than that. Let's go ahead and plug in these values for x and solve for the corresponding y values. We know that the original equation is y equals 7,500x plus 120,000. Let's replace the x with 0, and we get the equation y equals 7,500 times 0 plus 120,000. So we solve that and we get y equals 120,000. We can complete that part of the table. Let's look at the value when x is equal to 5. Going back to the original equation, we let y equal 7,500 times x, 7,500 times 5, plus 120,000. When we simplify this, we get y equals 157,500. Okay, now let's look at our final x value. Let's see what the value is after 10 years. Replacing the x with 10, we get y equals 7,500 times 10 plus 120,000. When we simplify that, we get y equals 195,000. Now let's use those points from our table to sketch the graph. We can sketch this just in quadrant 1 and label the x-axis as our years. X is the years after purchase. We can begin at 0 years, 1, 2, 3, 4, 5 years, 6, 7, 8, 9, 10 years. And then on the vertical axis, we wouldn't want to use each individual block as a 1 unit, but we can extend that to start the graph not just at 0, but indicate that there's a break in the graph here, and begin at about 100,000. And then let's use every block here as 10,000. So this would be 100,000, 110,000, this would be 120,000, 120K, 130, 140,000, 160,000, 180,000, and so on. 200,000 here. And that would be the value of the house. Let's plot the points from our table. When x is equal to 0 at the time of purchase, the value of the house is $120,000. After 5 years, the value of the house was $157,500, so about right here. And after 10 years, the value of the house was $195,000, so about right here. Now we can connect those with a line And you can see the value of the house increasing according to that formula. In part B, we want to complete the ordered pair, 5, comma, something. Well, in this case, we've already used that value in our table, so that ordered pair can be written as 5, comma, 157,500. And then we want to write a sentence explaining the meaning of the ordered pair found in part B. And we can say that after 5 years, the house's value increased to 157,500.